Momentum equals mass times velocity, with units of either newton seconds or kilogram meters per second. Conservation of momentum rule teaches us that the total momentum before a collision will equal the total momentum afterwards. Masses that join together, coalesce is the word for that, after a collision have the same velocity. Impulse is the change in momentum. The impulse A gives to B is equal to but opposite to the impulse B gives to A. And there's a second impulse formula, impulse equals force times time. If A stops on impact with B, what is the velocity of B after the impact? Let's look at the before situation first of all. So the momentum of A equals the mass 2 times the velocity 4, which is 8. And the momentum of B equals the mass 4 times the velocity of 3, which equals 12. Add those together and we get 20. So after the collision, the momentum of A will equal 0 because we're told that it stops, so the velocity of A afterwards would be 0. Momentum of B will be 4 times V, which we don't yet know. So the 20 must equal the 4V. Therefore, V must equal 5 meters per second. After A and B collide, the particles coalesce and move with a speed of 1 meter per second in the same initial direction as A. What is the mass of B? Let's look at the momentum before. So the momentum of A be 3 times 3, which is 9, and the momentum of B will be m times 2 m. Now notice in this case B is heading in a different direction to m, so it's going to be 9 minus 2m. Now let's look at what's happening after the collision, when they've coalesced. So the momentum of A will be 3 times 1, which is 3, and the momentum of B will be the mass m times 1, which is m. They said that they were going to move in the same direction as A, so this time we're going to add those together. So afterwards we've got 3 plus m. 4 equals after, and rearranging we're going to get 6 equals 3m. Therefore m must equal 2 kilograms. All of mass 30 grams is dropped 1.5 meters to the ground. Immediately after rebounding, it has a speed of 5 meters per second. Find the impulse given to the ball by the ground. Before we can work out the impulse, we need to first work out what the speed was just before it bounced. Know that the distance it dropped is 1.5 meters. It's acting under gravity, so the acceleration will be g. It was dropped, so its initial velocity was 0. We need to find that velocity just before it hits the ground. So we're going to use v squared equals u squared plus 2as. So v squared equals, the u squared equals nothing, so it's 2 times g times 1.5. And that equals 3g. And then if we square root that, we find that v equals 5.4 meters per second. Now we can do the impulse. That's going to equal the mass, which is 30 grams, but we need 0.03 because we want it in kilograms. That's going to be the final speed, which was 5, minus the initial speed, which is going to be minus 5.4 because it's acting in a different direction. That gives us 0.03 times 10.4. That equals 0.0312 Newton seconds. Here we have diagrams showing what happened before and after a collision, and we're being asked to find the impulse that A gives to B. Now notice first of all that we don't know the velocity of B afterwards. To find V, we're going to need to use the conservation of momentum formula. We're going to have 4 times 5 plus 2 times 2, so that's 20 plus 4, so that's 24 beforehand. After, we're going to have 4 times 3, and we're going to have 2 times V, so that's 12 plus 2V. 4 equals after, so 2V will equal 12, therefore V equals 6 meters per second. So the impulse will equal the mass of B, which is 2, and then we've got 6 now minus 2 times 4, which is 8 Newton seconds. Work out the force needed to increase the speed of a 2-ton train from 60 kilometers per hour to 70 kilometers per hour in 2 seconds. For this question, we're going to need both impulse formulas. Impulse formula, which is the change in momentum, and the other one, which is force times time. Before we can use either of these formulas, we need to do some conversions. First of all, we need to change 2 tons into kilograms. There's 1,000 kilograms in every ton, so that's 2,000. And then we're going to also need to change the speeds into meters per second. 60 kilometers per hour will be the same as 60,000 meters per hour. And then 1 hour is 60 minutes, which each have 60 seconds in them. So that means that there are 3,600 seconds in an hour. So 60 kilometers per hour will be 60,000 divided by 3,600. That equals 16.7 meters per second. Go through a similar process now for 70 kilometers per hour. You'll find that that equals 19.4 meters per second. Now we can work out the impulse using the momentum formula. So the mass is 2,000. Final velocity is 19.4. Initial velocity was 16.7. We calculate all of that, we get 5,400 Newton seconds. Now we're going to use the other formula. So that's going to be the force, which we don't know yet, multiplied by 2 seconds. So these two things will be the same. 2F equals 5,400. Therefore, the force F will be half of that, 2,700 newtons.